All right, now that I think I have myself unmuted, we're good. So we're going to do special cases. I promise this part won't take as long, but hopefully you spent some time going through the first part and you made sure you understand. And here we are at the second section. So in special cases, one of the things that happens is a self-contradiction. It's a compound statement that's false no matter what you do. So if this is true and this is false, and this is false, and this is true because they're opposites, and they're all ands. No matter which way I slice this, this has to come out to be false. That's a self-contradiction, okay? A tautology is the other side of the coin. It's something that's always true when it comes out. So when you get to the end of the line in a self-contradiction, you'll get a whole row of falses. When you get to the end of a line in a tautology, everything is true, no matter what. It means no matter how it shakes out, the entirety of what you're doing is true. An implication is a conditional statement that's a tautology. Basically, what it means is, we use this symbol for implication. When P implies Q, like if I tell you something and it implies something else, that means it's a tautology, it's going to happen. If I imply, gosh, I can't even think of something to imply right now. If I imply I wear only pink all the time, I imply that my favorite color is pink, and it's a safe assumption at that point, right? So that's what an implication is. When we imply something, that's what we're giving off, right? So we can go through and show that P, if P then Q, and P always implies Q. Okay, so if we do our truth table, oh, sorry, I need my P and my Q. Why am I starting that like that? Okay, back to pen. Okay, true, 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 false, false, true, false, false. Well, what do I need first? I need P, if then Q, right? And we know that that's only true, false, when this promise is broken, right? So no matter what I do, it's true unless my promise is broken. So if I take that, this P, if, then Q, and I add on a P. Ooh. So I'm going to just ignore Q for the moment. Those are both true. That's false. That's false. That's false, right? Oh, something's lined up wrong somewhere. False, true, true, false, true, false, false. No, that's false. That's true. I did something funky somewhere in my truth table. I hope you see it. I wonder if I can see it. Well, essentially what's going to happen normally when I don't do something silly because my brain must be tired is this should be true because the whole thing should come out true. Maybe I'm looking at the wrong columns. I'm looking at the wrong columns. That's what's happening. Okay. I'm matching here to here. So, okay, my brain melting. Here's P, if then Q, and we get everything matched up. Okay. Sorry, my brain melted for a minute there. See, it happens to me too. A biconditional statement that's a tautology also tells us something. When two statements have an identical truth value, they're logically equivalent. So it tells us that both things on the side, both sides are logically equivalent. This is the symbol we use for logical equivalence, okay? So sometimes what we test for is to see if things are logically equivalent. If I tested out the truth values of P and Q, then R, or not P or Q, not Q, pardon me, then not R, we could test all the way through and find out that the set of values I get here, I'm going to end up with 4 trues. Here, I'm also going to end up with all trues. Sorry, all the way down. I'm going to run out of room. So what happens is if that comes out to be the same in both cases, that's logical equivalence. That means that they're worth the same in the end. When two statements are equivalent, they have the exact same truth tables in the answer column of their, or truth values in the answer column of their table. When you want to know if two statements are equivalent, what you do is you make a truth table and you compare them like this. Okay, you can work through the truth tables for here. And for here, you have the skills to do that now, and you can prove that they're equivalent. All right, a couple more things. So here are statements that I can compare. The bread is baking and the bread is hot, right? Okay, so what I want you to do is write out each statement in symbols and compare them and see what happens. So if the bread is baking, then the bread is hot. And if the bread is hot, then the bread is baking. So you're going to do a truth table for P if then Q, and Q if then P. And then you're going to do a truth table for P if and only if Q. And what I want you to figure out is if the last column in each is exactly the same. They should be. So take some time and figure that out and see what you get. Okay? What you should get is the ability to compare them. You're going to compare the truth values. All right. When this happens, this is what we just did here. These are logically equivalent. Another thing that's logically equivalent is P if then Q to not P or Q. Okay? When we see that, either of them, it means this side, the left, is interchangeable with the right. We can swap them for each other. They're equivalent. It's like 5 is the same thing as 2 plus 3. There's another equivalence type of thing here called De Morgan's law. What it says basically is that I can distribute this negation, but when I do that, the and changes to an or the or changes to an and. Okay, these are equivalent to each other. Whoa, too fast. And there are some variations of things in the conditional. These are important for you, so make sure you pick these up. Converse, inverse, and contrapositive. So what we can do is we can take a conditional, right? So a conditional is if P, I'm going to just do it in symbolic, right, and say them out loud. P, then Q. The converse, it switches the order of them. The converse of P, if P, then Q, is if Q, then P. The inverse negates the original. Okay, so the inverse is not P, if then not Q. And then the contrapositive is both. So what you do is you have not Q, then not P. Okay, and we can do this in words. So if I have $1, then I can afford to mail a letter. This is my P, and this is my Q. The converse is switching them around. So I'm going to do Q if I have a letter, then P, I can afford to mail $1. Okay, or I can afford, then I have $1. Pardon me, mail $1. The inverse is the nots. Not P, then not Q. So I would write, if I don't have $1, then I can't mail a letter. And then the contrapositive is not and reversed. Oops, not Q, then not P. So if I can't afford to mail a letter, then I don't have $1. Okay, do you see how these work? Try them out. You'll have some to try in the homework as well. So we can create a truth table for this. We're actually at this point going to move on. We've tried that. Okay, but if we write the converse, inverse, and contrapositive of these pieces, so the converse, remember, switches the order. So I'd be having not Q, then not P. The inverse is the negation. So the opposite of not P is P. The opposite of not Q, oops, is just Q. And the contrapositive is both switch the order and make the inverse. So it would be Q, if, then, P. All right, there's two other laws, three at the end here. One of them is called the law of detachment. Basically what it says is that if P, then Q, P, therefore Q. So if I have a valid argument here, okay, then I know that this is a premise and this is a conclusion. If this is true and this is true, then Q is also true. So if on cloudy days I wear a hat, today is cloudy, then I wear a hat, okay? Here's another one. If P then Q, this is called modus tollens, it's contraposition, and not Q, then not P. So if it's cloudy and I wear a hat, then I wear a hat, and I'm not wearing a hat, well, it's not cloudy. That's what you can conclude. And then the last one here is transitivity. It's called the chain rule. So basically, if P then Q and Q then R, then I can cut out the middleman, P then R, okay? So if they relate to each other, they can connect. All right, so I told you that section was shorter, and it was. That is the end of the notes for 2.1. You will have access to these videos as you work and go through the assignments in this section. As always, as you have questions, you should reach out. I'll see you in the discussion board, and I look forward to your assignments. I'll talk to you in a bit.